My name is Jim Ford. I am here to talk about what I call software-defined chaos. As you start to look at the software-defined everything movement, you run a high risk of getting involved in things that are great for the moment, but probably not long-term for the planet. And you run the risk of buying into something that becomes a dead end off of the main highway instead of being on the main highway. So we're just going to talk a little bit about that. Just to start, I come from ADP. You probably have heard of us. We're a very small company, about 650,000 clients. We have about 35 million users. We do business in about 120 different countries. You can read most of this for yourself. As you can see, we tend to get a lot of awards about working for us or with us and using our technologies. You know, if you're looking for work, please consider us. We're always looking for more good people. What do we do? Well, we do the full HCM spectrum. We do hire to retire. I know there's a lot of companies that talk about hire to retire, but we do have a lot of products in the front end of screening, selection, recruiting, applicant management, all the way to 401k record keeping for your retirement planning. So it is truly across the whole spectrum. We have grown-up challenges, I like to say. They're not really the typical challenge you see in a small company, because with clients comes challenges. I know a lot of you are sitting there going, really? Having no install base can be your best friend, because then if you start up on a services as a platform or in the infrastructure or a platform as a service, you don't have to worry about what you did before. And you know, when you're working in a world where you do have clients, now you have these things that you have to bring forward with you and figure out how are you going to keep them happy while you transition them from what they know and love into what you now know and love. So we have about 100 applications, a little more. We run around 50,000 servers in our data centers, and for this purpose, a server can be a VM or a physical or a whatever, just trying to give you an idea of the scale. There's a lot. We have a lot of things that we run concurrently where we have clients on a variety of versions and the clients want to migrate at their own speed. So we run some old code, some new code, some middle-of-the-road code, and it balances out through its life. We have several efforts across our innovation labs and development centers where we're trying to self-disrupt ourselves. We're not blind to the people out there who are trying to eat our lunch, and we know that being a $8 or $9 billion company, there's a lot of lunch to be eaten. So we have to be careful and make sure we don't lose our advantages. And one of our goals is to create developer velocity and consistency. We want things that are going to operate the way we expect them to operate, even in this world of software-defined everything, where the level of uncertainty rises up further and further. So, you know, what we're really trying to do is handle the chaos and enable our future. I think we're all trying to do that to a great extent, whether it be our daily lives or in our corporate lives. So one of the things I see a lot of is people tend to not solve the problem they're actually having. They get very caught up in, oh, look, I found a cool way to solve problem X. Well, do you have problem X? Maybe, maybe not. You're probably solving the problem you don't have because you got caught up in, oh, well, Google did this or LinkedIn did that. So trust me, most of us are not Google or LinkedIn or Amazon. We do not have the class of problems they have. And this is a link to a blog post that you can pick up off the deck later, or you can Google the "You are not Google." And the gentleman makes some very good arguments about you're making trade-offs. You know, people look at Google and they see, ooh, MapReduce. MapReduce was the thing that saved the world for Google. Well, Google had a lot of scale. And MapReduce is kind of an inferior query product to a typical Oracle or SQL Server or any normal SQL database if you're at a scale that fits in a single box or a small group of boxes. You know, MapReduce becomes a problem for people with petabytes of data, not gigabytes of data. So LinkedIn created Kafka, a wonderful messaging system that is great when you have trillions of messages. Well, do you have trillions of messages? I'm not sure I do. You know, we have to think about what we're doing and why. And does it make sense to say, you know, I have hundreds of messages. Do I want to use Kafka because I'm really thinking about the upside? There may be a valid reason, but you've got to balance that back and forth between what's right and what do you want. The Amazon reference here talks about Cassandra database. Well, the Cassandra database was optimized for writes because Amazon didn't want to ever lose another shopping cart, because the biggest problem in online retail conversion is dumping of the shopping cart when the user goes to check out. They're not going to go back and put things back in their shopping cart, so Cassandra was built to be very, very write available. Well, if your workloads read, don't use it. So you really have to think about these things because software lives a long time. We create a lot of new software, but you don't hear a lot about people turning off old software. So you want to make sure that you make the right balance of decision and make sure you're using the right tool for the right job. And I make the point here, it's not always the cool new toy. I'm going to coin a new term for you guys, resume-oriented architecture. This is where I go ahead and decide what technology we ought to use on the new project based on where I want to work in the future. Nothing to do with your success or failure, but my resume, damn it, really needs Cassandra, so I'm going to go and do something and say, no, this is the one thing we really need to do. So this makes the point that we have a very complex landscape today in the cloud native world, and this is directly from the Cloud Native Foundation's page for their landscape. And if you look at how many buckets you have of different functionality, and then you start to look at how many are in each of those boxes in terms of overlapping or equivalent functionality, and then think about how you can permutate your way into a really bad place by trying everything with everything, you can get into kind of a rabbit hole very easily. And there's a reason it's on an alien landscape, in this case the moon, because you can get into a place that you're not going to like very quickly. So you have to embrace the uncertainty that comes with software-defined enterprises, but your goal is to get those layers of defined infrastructure and everything to be visible and manageable, performant, repeatable, consistent. I argue here, and you've probably heard about Schrodinger's cat at some point or another. It's a quantum physics example of how a cat is both dead and alive until the observer opens the box to see if the cat has died or is still alive. Well, you can end up with Schrodinger's app because you've used so many things that are defined at such a high level that until the user actually clicks on the button, you really don't know, are you up or are you down? And that could be very nightmarish because your monitoring can say, absolutely, you're great, but your users say, no, you're not. So you want to make sure that you're doing things that are at least somewhat deterministic and that you're not relying too much on hand-waving and smoke-blowing. The software-defined enterprise promises a great deal of flexibility and speed and great things because now you can say, I don't want to pay for DR, I want to have a script that stands up a whole business in one click when I need it. Well, that could be great, that could be terrible. You still got to figure out what you're doing for your data and other things. And as you saw in that landscape slide, there's so much polymorphism of so many different things out there that you can use that you need to consider, what do you want to adopt when? The PaaS, the platform as a service, the IaaS, or even the service as a service evolves so quickly that what you thought you had to integrate yourself last year may become a platform feature next year. And you can see that every year if you go to AWS reInvent. They have the Keynote, and by the end of the Keynote, half the vendors on the floor have become obsolete because Amazon just announced updates that included the functionality they were trying to sell you. So, beware. Don't go too far out on the bleeding edge because, it will be a problem. Emulation, software-defined everything implies software emulation of physical things. There is no free lunch. Emulation equals overhead. You're lying to the hardware, you're lying to the program about what it's talking to. So you have to remember there are trade-offs. Software-defined networking is 2 to 4 milliseconds for local devices talking, where physical hardware, the hardware switch, is still less than 1 millisecond. Now, do you care? Well, if you're a high-speed trading platform, yes, you probably do. If you're a site that posts cat videos, well, maybe you don't care. What's a few milliseconds to get the benefits and the cost? So I'm not saying don't do it. I'm saying go in with your eyes open and think about what your ramifications are and what the upside and downside is. Avoid what I like to call the shiny object management theory, which is, hey, we've got this great idea, we don't really know how to do it, but we better start now because we can't afford to wait any longer. And I love this, Dilbert, because, you have Wally sitting in his cube going, of all my projects, I like the doomed ones the best. Because after all, he's supposed to be writing code, and what's he doing? He's reading the newspaper. And he's just as productive as if he would have been writing code, because the code was probably worthless too, because he hadn't defined what it's supposed to do. So you have to remember that a prototype or a proof of concept should never be considered production code. Too many times I've seen people step into a situation where they go ahead and say, well, it's working on my machine, let's ship it. And that's great, but for a little while, but you really have to have a backstop plan for how you're going to make it robust and capable of what you're trying to get out of it in the longer term. Because if you go ahead and don't do that, you're going to spend all your time patching and praying and trying to recover and get stability, instead of spending a little time up front and refactoring that POC into something you can live with over a longer period of time. Remember, it's called the bleeding edge for a reason. If you're at the front of the knife, you will bleed. So try to pick technologies that have at least proven themselves a little while, that have gained some level of adoption where it's not you and 3 other guys who think this is the right answer. And while the internet has been wonderful for us, it's created a paradox around what's considered the cult of the amateur. So, you see this in climate change. There's a lot of people with PhDs saying it's real, and a lot of people with personal opinions that say, no, you're full of crap, it's not real. Well, do you believe the expert or do you believe the amateur? Well, on the internet, we have a platform where the amateur's opinion has been elevated to that of the expert, and they're difficult to tell apart any longer. So I love this graphic as well. Help me, Stack Overflow, you're my only hope. Stack Overflow is a site where developers go to Google, in essence, or look up and search solutions to hard problems in code. Now, is that the best solution? Well, no, it's the expedient solution. And being quick is great, but you got to be fit for purpose as well. So you have to be worried that the people you're working with are relying too heavily on a Stack Overflow and Google to write their code. And I'm not sure I consider someone whose 2 primary skills are Google and Stack Overflow searches to be a developer. I typically think that they're more likely an experimentalist or a hobbyist, and you probably don't want to be paying them a salary to write software for you. I know there are people out there who will be very depressed to hear me say that. ADP, we've been doing a lot to try to mitigate our risks as we move into more of the software-defined world. We've partnered with Docker to be one of their 2 primary enterprise clients, and we've been, very serious about our adoption. We've gone from 400 Docker engines and 1,000 containers in October of last year. This summer, we were up over 600 engines and almost 4,400 containers operating. 30 to 40% of those containers are actually running in our data centers doing production workloads for our clients. They're not just science experiments back in our development lab anymore. But early adopters, find the problems. The old adage about the pioneers take the arrows, there's still a little bit of that out there. And we've had challenges in the software-defined networking. We've had problems in software-defined storage. And that's an interesting problem because the answers are different, whether you're running in your own data center or if you're running on an Amazon or a Google platform. And then there's the whole question of when will Docker and the container native folks solve storage as a general first-class problem. And then all these companies that are selling software-defined storage platforms will become white elephants. And if you've embraced them too deeply, you'll have a migration problem from hell as you try to extract your data away from what you've put in there to solve your problem and get moving again. So, the platform, you have a lot of challenges keeping up with the rate of change. A lot of these platforms like Docker are on 2 or 4 week cadences on releasing major feature updates, which is awesome and horrible, because the bigger your adoption, the longer it takes to get those out. And you've got to try to pick how are you going to get there. And then you get what I consider to be uneven platform support. The ecosystem is not maturing at the same rate. The orchestrators are moving toward Kubernetes while the platform authoring is moving toward Docker proper and the like. So you have to figure out, do you wait and run the risk of being late, or do you run forward knowing that your percentage of rework is going to be higher than you would like because you are taking chances? There was a gentleman from Forrester at a container summit a year or so ago who made the point that if you wait till you're comfortable with the technology, you're probably too late. So you've got to balance between the how am I going to avoid being too late and how am I going to avoid being too early. And partnering is one way to do that, and it's worked for us in many ways. We're trying to work our way through automation to tame the chaos and get consistency so you can get repeatability. And this is an example of what we're trying to do with our build automation. And it's illustrative only. It's not, don't go home and write down which vendors to use and say, oh, Guy, we got it. There's a lot of different folks doing security scanning, white source instead of black duck or whoever. Artifactory's great, but you can do that with the DTR from your friends at Docker as well. So, there's lots of different ways to attain this. But I think the real key is to figure out how do you get away from doing things manually. And you've probably already gathered that if you're out in the public cloud and you're doing things manually, you're hating life. You're running around like a crazy man going, how did I let this happen? It was bad enough when you managed your own infrastructure and could see what was happening. Now you've given that to a third party. You've diminished your visibility. You've diminished your ability to get in and look at what's going on. Yet you're still running manually, so now you have another layer of abstraction you're interacting with, and you can't troubleshoot effectively. You've really got to get there after you've got the automation down. And once you've gotten, say, this far, then the decision about public cloud, private cloud, whoever's cloud becomes a relevant discussion that's based on cost, not capability. And that's where you kind of want to be, unless you want to get, become a boiled frog and become trapped in one of these cloud providers because you've used something very special and powerful. Not that you shouldn't use those things, but go in eyes open. If you become the biggest user of Redshift on Amazon, remember, you're now Amazon's partner for life. You're not going to move off to Redshift on Google Cloud because they're going to be big table and something else, and your stuff's not going to be portable. So portability is good in most cases. Maybe there's times it doesn't matter. So really, here's my argument for you, which is, you have to balance your complexity with your ability to manage it and deal with it and understand it. We've chosen to go into a loose coupling via APIs. We have a very much of an API-first mantra at ADP these days because we've come to accept that we don't necessarily know how the software will be used tomorrow. For legacy stuff, we're using an encapsulation and isolation model where we still expose the APIs. And microservice purists always get upset because how can you say you'll use a monolith? And I'm like, well, if the microservice is only exposed via an API, why do you care? If I expose monoliths via API, I can look at my traffic and look where my rate of change is and then do refactoring in microservices where it makes sense to do that, rather than try to cheese grate my monolith into microservices where my best case is I have the same thing and my worst case is I don't. APIs are enabling new functions as microservices, so when you do see that rate of change or that area that has a lot of functional deficit, you can certainly augment there and build new stuff out. There's a lot of things you can do once you have the API because the user interface has become kind of secondary. How many of you run home to your computer every night to check email? I see a few phones up. I suspect that you're using that to do that function and not waiting until you get home tonight. Well, if my email only worked on my laptop and didn't work on my phone at this point, by the way, you can thank APIs again for that being possible. It's not the model. We're into polymorphic consumption now. The consumer experience is shifting so rapidly that you're moving into mobile, to voice. Look at Alexa and the skills that come along there. Look at the ubiquitous computing, augmented reality. Soon you'll be talking to the buildings about where you want to go or what you want to do. You won't be looking something up even on your phone anymore. Maybe we'll go back to the president's analyst and they'll all insert a chip in our brains. Hope not, but could come. as we expand, we got to think about how we expand. And I would tell that anyone here who is responsible for a product that's out there today, that you really need to consider how you open your APIs into that open marketplace and make it available for folks to use in ways you didn't think about them using them. ADP has created the ADP Marketplace where we expose a lot of our core functionality. So if you're building something in recruiting or time or HR analytics, you can integrate with us and our clients can buy your product off of our marketplace, much like you can buy something from your App Store from Apple or from Google Play, and click your way through making it work against the data you're already using and caring for as part of your normal business process. Just want to thank you all for listening. If you have any interest, developers.adp.com is where we have our marketplace shingle out, where you can look and see what we think it looks like. I do answer most emails. Just remind me that you heard me talk at SDXE. Thank you.